Oh man. Okay. Alright. Who missed today? Who's that? I didn't see it. Usually you're always walking late. Hey, welcome to the starter class.
Yeah. Christopher?
I'm James in the restroom, but I think he told me this. Okay, today, what we're gonna do a couple notes on graphing, and then what we'll do is I'll turn you loose on your homework here. Let me pop up a graph here so you have one. All right. Oop. All right. So the first couple problems that they're going to have, let me mute this for right now. We're not going to need this. Okay, the first couple of problems are going to give you information, and they're going to want you to take that information and put it into one of these forms. Okay, so that'll be your first couple of problems. I'm going to do probably about 3 different examples of that right now. Some of them will look almost identical, but the first one is probably the most unique one. Okay, so here's what they'll do for the first couple. They'll give you a slope for your problem. So somebody give me a slope, please. Say it again. 3. Okay. And give me a coordinate. -1,7. Okay. So if this is what they give you, what they're going to ask you to do is they're going to ask you to take this information and put it into one of these forms. Okay. The traditional one that they always kind of go to is that they traditionally want you to take this information and write it into point slope form. That's the one that, from what I saw in the book, that is the most common form that they're going to ask you for the ones I picked out anyway for today. The reason why is point slope form is the easiest. If you have information, it's the simplest to plug information in. I mean, these problems should take you 2 or 3 seconds because when you have that information, this is the form we're going to. So let me write that form down. This is point slope form. Y minus y1, m x minus x1. Right? That's the point slope form. It's written right here. I'm going to leave these on the board today so you know which form they want you to write it in. Okay, so if they give you this information, well, this is pretty easy. The slope goes here. Right? So that's my slope. That was the 3 that we came up with. Then the coordinate, this thing goes in your x1 and y1. So this is your x1 number, this is your y1 number. Okay? It's your first coordinate that they give you. So the x1, this -1 will go in here. You can leave it like this, or what's negative? Positive. So you can write it like this too. That means the same thing. Okay, I don't mind which one you put. And for the y, we go y minus the 7. And that will have to stay that way. I don't care which one you pick. This is kind of what they want for the home. One of these 2. Does that make sense? They're going to give you, I think I gave you 3 of those. Okay, so you plug in the slope, you plug in your coordinate. They just want to know what the equation is. You don't have to graph, nothing like that. Just what is the equation that represents that. Okay? Questions, comments, concerns about those? About 2 or 3 of them. Now, here's a question to you. Does anyone need another one of those? Another one? Okay. Make up any numbers you like. Give me a slope. Taking information, plugging into the equation. You said you want another one?
Oh, I thought you were going to graph it.
No.
No, you're fine.
Okay. Anyone else? Anyone else want another one of those? Okay. I'll take your silences now. Let's go to the second type. Now, the second type of equations are going to give you something a little bit different. They're going to give you something like this. They're going to give you 2, 3, and let's say this is 3. Actually, no, let's not go 3. Let's go -3, comma 4. Let's say that this is what they give you. Okay, they're giving you 2 coordinates. Now, they don't want you to graph. All they want is take this information and write an equation Write the equation of the line in point slope form. Well, that's the same equation you just came up with. It's that equation over there. But now, notice what they give me here. Did they give me slope?
No.
No. They gave me a couple coordinates. So what we need to do is we need to first, because we need to go to this form eventually, point slope form. So we'll have to get to that here in a little bit. In fact, let me write that over here. Y minus y1, m, x minus x1, okay? So they're gonna, my goal is to get back to this form again, but I need to find slope first. So if you don't remember what slope is, this is your slope formula. You subtract the y numbers, you subtract the x numbers. That's what we did in the last one, we just got done with the other day. That was the page 193 stuff. So if we're finding slope for this, actually subtracting these numbers, that it doesn't matter which order you pick, as long as you stack them. I'm going to go, let's go like, this is my top one, -3, 4, and let's put this one on the bottom, 2, 3. Okay, so I'm going to subtract the y numbers. These are the y numbers, these are the x numbers. So the y numbers on the top, 4 minus the 3, then the x numbers on the bottom, -3 minus the 2. I have to go in the same order, that's why I went top minus bottom. And so this turns out to be a 1 over a -5. That's a negative slope. So if we were to graph that, the line would be going down. We don't have to graph the line, but that's my slope. So that number goes here. So we have my slope is 1 over -5. Okay, questions on how I started that? Found slope, which we did in the alt last semester, so you should be pretty good at that. And now we want to go to point slope form. Okay, now that we're here, I need one of those coordinates. Which one do you like better? 2, 3? Yeah, I agree. That's probably the easier looking one. So we're going to pick one of the coordinates. That coordinate is going to be my x1, y1. That's going to be the coordinate that's going to go into my formula. You could have picked any one you like. So it didn't matter which one you wanted. I just picked one of them. I just picked the easier looking one. So the x1, this is my 2, so that's x minus 2, and then my y1 is the 3, so y minus 3. This is what they want. Okay, makes sense? Like that's what they want. They want the equation in point slope form using that information, so you have to find slope and then pick one of the coordinates. It has to be one of the coordinates they gave. Now, here's the thing that I kind of want to warn you about this problem. This problem is the one type of problem that I'm going to probably give you the most today. You're going to have, that'll be the most, because you have to find slope, so you have to practice doing that. And you have to take that information, plug in the equation. That information can be given to you many, 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 many different ways. Okay, they could give you the coordinates very explicitly like this, and that's easy. They could give you a graph. So if I go to my graph here, where's my graph? They could give you the graph, and it would be the exact same problem. They could just draw dots here and draw the line and ask you for the same information. Right? They could give you the 2, 3, 2 times 3. They give you the -3, 4. And they could, and they might, I think what they do is when they give you graphs, they kind of list these off. They give 3, 4, 2, 3. They'll ask for the same thing. Given these coordinates, find the equation of the line and point slope form. It's the same problem. It's just, it looks different, right? They give you the graph as opposed to just giving you the coordinates. It's the same problem. That was the exact same. Now they could also do the same problem, but they might give you a table, where they do something like this. Table is 2 and 3 and -3 and 4. That's the same problem, right? They gave me my coordinates. It's just a table, though. They might say in the instructions on this one, given these coordinates, write the equation in point slope form. This is the same thing. This is a coordinate. It's 2, 3. That's a coordinate. That's -3, 4. Because you have to look at which ones are my x's. These are the x's. These are the y's. I know that I think in one of my pre-calc textbooks, they did something really evil to one of my pre-calc questions. They did something like this. They did that to one of my pre-calc classes. That is still a table. It's just that the coordinates go down instead of across, because you have to look at x, y, x, y. So this is one of the coordinates, that's the other coordinate. That was just, I thought it was super evil that they wrote a table like going horizontal as opposed to vertical. But it's the same idea. You have to look at where the x and y number is. They're kind of paired together. So far, I put 4 examples on the board. They're all the same problems. That same exact thing over there. Same coordinates. Okay, any questions with that problem? Okay, I'm going to leave that one on the board. That's probably the one that you're going to have the most today, so I'm going to leave that so you can kind of look at that one. That first one, this one was kind of easy. Just kind of plug in the coordinates and slope. I don't think you need to see a bunch of those. Okay, now the last style of problems, because there's 3 types of problems. There's the one I did earlier, there's this one, and the last one is, I think, the one that's going to take you the most time. I don't give you a lot of these. I think I gave you 3 of these. But it does take the most time. And what this is, it's asking for parallel or perpendicular again, which was from your homework, right? Finding parallel lines and perpendicular lines. But there's a secondary part that makes this one difficult. Okay, in fact, I'm going to pick one from the book. So, in fact, I'm going to let, then you get to pick this up. Okay? So, it doesn't really matter. Just don't pick 30, please. Okay, so don't pick 38. That was kind of a rare one. So you can pick 39, 40, 37, or you could pick 10 or 11. It doesn't really matter. They're all those.
Okay, maybe 37.
Okay, so say it out loud. What again?
Passes through -7, comma 4,
7, 4, okay.
perpendicular to y equals 1/2 x plus 9.
All right, and we got to be perpendicular to that?
Yeah.
Okay. Okay, so this is that rare problem. I think I give you 3 of these. You need to pass through this coordinate. We want to be perpendicular to this. The whole goal in this, in the instructions, they want the equation of the line in point-slope form, and they want you to graph it. So this is the 3 problems you almost definitely have to graph. Okay? So I will provide you graph here today. So we are definitely going to have to graph this. So we're going to be passing through -7, 4. So 1, 2, 3, 4, 5, 6, 7, 4. Okay, so here's the coordinate I need to pass through. This is my point that I'm going to pass. I'm going to be drawing a line through there at some point. That's what I'm going to need to graph. Now, I need to be perpendicular to this thing. Okay, what it means to be perpendicular, I have to be at 90-degree angle to this line. This is a unique line. It's not going through that thing. This is a different line, so we have to graph this. So you have to get some practice graphing. This is my y-intercept on this line. That's where it's hitting the y-axis. This is my slope of that line. So this line is hitting 9. So here's 9 on the y-axis. That's my y-intercept, and it's going half. It's rising 1, running 2, rising 1, running 2, rising 1, running 2. And let me draw that line. That looks like it's pretty close to that 7. Okay, good. It did miss it. Geez, that was close. Okay, so we need to be perpendicular to the green line. That was really close to that green line, by the way. So we need to be perpendicular to that thing. So what I'm basically looking for is the equation that's going to do something like this. Be perpendicular to the green line that's passing through P. And then what's the actual formula for it? Now, the thing you need to realize, perpendicular. Since this is my slope of this line, right? The slope of this line is half, right? What is perpendicular slope? What did we talk about in that last assignment? How do you find something that's perpendicular? What do I do to this thing? It's an opposite reciprocal. So if they say the word perpendicular, I do the opposite reciprocal to the slope. The reciprocal means you flip the slope over, and then you do the opposite to it, so that means negative. So really that slope now for my problem, my line, is going to be just -2, right? -2 over 1 is -2. So that's slope. You can leave it a fraction, not a big deal. So this is the slope I'm going to use, and this is the coordinate I'm passing through. Now to draw this is easy. Slope is, you rise and run. So dropping 2, running 1. That's slope. Because my rise is to drop 2, run 1 to the right. Drop 2, run 1, drop 2, run 1, drop 2, run 1, and I can draw the line. Okay. Pretty easy. So that's simple enough. Okay, but I need the equation. And that's what you're basically doing over there. I have my coordinate, I have my slope, now I can come up with the equation for it. Y minus y1, m x minus x1. So my slope, that was the -2 that we just found a little bit ago, that's perpendicular. And then what was the coordinate that they wanted me to pass through? -7, 4. So the -7 is my x number, right? This is my x1 number. This is my y1 number. So I'm going to be subtracting the -7. So that makes it a plus, technically. And then I have to subtract the 4 from the y. This is what they wanted. That's the equation in point-slope form for the perpendicular line to this thing. And the only thing I needed this thing for was just find slope. That's all I needed. Okay, does everyone understand what perpendicular is? That was it's mixing the last homework we did with today's homework. Okay, any questions, comments about that problem? So, equations of lines, the different forms. This one happens to be perpendicular, so you have to know it. Now, if they said parallel to this thing, I would just use the same slope. I wouldn't flip it. I would just use that instead. Okay, you think you can handle these 3 types of problems today? The first one I showed you earlier, those types of problems, which are pretty much the most of your homework today, are those with the equation. And then you're going to have the last few where you have to find the equation and draw it. Okay, if they ever say graph, you have to draw that type of problem. You have to draw it. Okay, all right, here's your graph paper here today. I'll put the homework on the board. This homework is going to be due on Thursday this week. It's a rarity. Usually it's longer, but this is pretty straightforward. I think most people get it probably done if you start today, because you have about 20 minutes. And I need graph paper. You won't need all the graphs. I was just printing by default. It's 12. I think you only need maybe 6 or 7 graphs, something like that. You don't need them all. All right, here's your homework today. Let me put it on the board. Okay, homework today. Page 202, 13 through 15. 20 through 22, 28 through 32, 35, 37, 39. Okay, there we go. There's only a select few that you have to graph, so just be careful and look, see if did they ask you to graph or did they not. If they don't, then pretty much all they want is the equation. If they ask you to graph, you have to do the equation and the like that. I think the last 3 for sure are these. Perpendicular, parallel, that. There you go. The 7 is yours. You can move around. You can kind of sit wherever you want. Video from yesterday, I think it's being posted today. So if you get a chance today at home, check out that video from the GoPro and the DLSR camera. See which one you prefer. I was going to post them last night, but it took me long to process.
Want your book back?
Yes.
Yeah, I'll keep it.
Appreciate that. I'm sure you guys want that.
Why does mine do this? That book thing. Like I have to enter the book thing. When I go add, then
You haven't entered the book yet? I think you did.
I guess not. I've never used this before.
Oh, you haven't?
I didn't know. I thought it came like you had to type
No,
it in.
you've logged in, right? So now you
Yeah, no, I just use that code.
Let me find it. What's up? Your connection is not private. Or restart. Are you connected to Wi-Fi?
Yeah.
Yeah, restart. Do that. Alright. So Bailey, let me give you your 12-digit code here.
Okay.
Alright, here you go.
Okay.
Okay, you got your code? Okay. These are in capital letters. I don't know if it automatically does.
Oh, okay.
R5
Yeah.
CZ dash CH NT DJ for that's an O.
Or oh, alright. See. Yep. Sure works. Alrighty. Thank you. Okay.
Paige, yours work yet?
I don't. There's like things that I have
Fair
I don't
enough.
have to have preparing for yourself. I'll figure it out.
Okay, sorry.
Okay.
You can throw it. Yeah, there's only a few that you have to graph.
Like the last,
Like 13 through 15.
13 through 15 says graph. I think the last three you have to graph. The parallel
20 through
for
22.
yeah. It says graph.
It says after.
You won't need all the graphs in your paper, just a select few. I think there's maybe 7 or 8. Something like that.
oh, I see.
Yeah. Okay. All right. Questions? What do we got? Okay.
Oh,
All right. Question. Yeah. Certain ones they say graph. Yeah. There's only a select few. You don't need all. Yeah, just remember, y-intercept is where it crosses the y-axis. If you want to know what that is as a coordinate, you know, if you're going to cross the y-axis right here at 2, that coordinate is 0, 2. Like, if you need the coordinate for it.
Would it still be a negative though? What's your
Alright, what do you got?